Welcome to Lesson 2. Today we're going to work on term combining and two-step equations. Again, this is a review from what you've done in Excel. I can combine like terms, then solve the resulting two-step equation. Before we get started, we're going to work on some common errors or discuss common errors so you can try to avoid them. And we're going to work with two expressions and work with term combining, and then we're going to try to work on another common error in an equation that requires us to combine like terms. So our first example, the most common error, would be to just try to combine all of these terms. So I have 4x plus 5, so 9 plus 2x. So sometimes this is written like this. And unfortunately, we cannot do that. What we should do instead is identify our like terms. I'm going to erase this, and this is what should happen. We should gather up our like terms, and sometimes what's called the boxing and circling method is used. I'm just going to show you that this 4x is like this next term, but what's very important is I take the sign in front of the 2x with it. So these are both considered like terms because it did the same variable raised to the same power. Speaking of which, if I had this 2x and x squared, it had an exponent on it, it would not be a like term. So it has to be the same variable raised to the same power. So now this 5 is different. It does not have the x variable with it. So I would put that on a separate line. Noticing that I took the sign with it, I can either just write it as 5 or write the plus 5. I'm going to look at it like it's a positive 5. Now our goal is to combine the coefficients, the numbers. So I have 4x's plus 2 more x's here, meaning that I have 6x altogether. That 5, because I didn't take the sign, but I could have, it's a positive 5, so if I look at this as a positive 5, I can write plus 5. If this would have been a negative 5, if that's a what-if question, I could have written it either as 6x minus 5, I could use that like it's a negative, or plus a negative 5, but I would have to not acknowledge that it's negative. Since that's not the case, I want to erase that and make sure that that's not something that I've confused anybody with. So our answer is 6x plus 5. Our next situation, gathering up like terms, I would start with the a's. I see 7 a's, and I see 3 a's. So I might write that as negative 7a, and then I have a positive or 3a there. There's my mistake. I did not include the sign, so that should have been a negative 3a. And then again, another mistake might be taking that 2 as a positive 2b instead of a negative. So if I didn't acknowledge that negative and I just went after the terms without their signs, that's where I could get in trouble. So if I looked at this particular example, I might think that this is 4a or negative 4a, and here, if I didn't acknowledge that minus sign in front of the 2, I might just think that there's 8b. So this would be a common error. So you do not have to write this down. That's actually the wrong answer. So what we want to do instead is we want to make sure that we gather up those signs along with it. So I would again start with my negative 7a, and I have to acknowledge that negative 3a or minus 3a. So I'd have negative 7a minus 3a, or plus a negative 3a if you prefer to do it that way. And then I'm going to gather up my b's. It's a negative or minus 2b, and a positive or plus 6b. So I'm using my plus signs interchangeably with positive signs. I'm using my negative or my minus signs interchangeably with negative signs, and it's whatever makes it a little bit more comfortable for you. So when I gather these two up, if I have a negative 7 minus 3, or if I think of it as negative 7 plus negative 3, either way I should get negative 10a. And here with the b's, if I have negative 2b plus positive 6b, that's going to be a positive 6b. So this is the answer that we want. And by far, the most common error when combining like terms are the signs. So now let's see, in our last example, what might be a common error. When we are given a problem or an equation like this, we want to simplify this as far as we can, meaning that we want a number, a coefficient with all of the variables gathered up, and we want a constant. But a common error, and it's doable, meaning that you can do this, but I've seen many errors after it when we do it. Some students start solving because it says to solve the equation. So we could do that, but we not only have this 5a, we also have another, 5n, we also have another n, and that has to be acknowledged. And in the past, that's been very confusing to students because they're not quite sure what to do with these two groups. Since we've only eliminated plus or minus 12, we have to drop down all the pieces. We could continue this, but better way to start is to simplify the equation first. So instead of solving it, first we want to simplify it by gathering up our like terms. If I have 5n here and another n here, that'd be one more n. I'm going to add them together. I'm going to get 6n. This is a different term. It doesn't have an n, so I'm going to drop it down along with its sign. I'm going to use it as a minus 12. That's going to help me solve. And then this other constant hanging out on the other side is just going to drop down. Now we can solve. So at this point, I would add 12. So we did use the right solving step last time. We just didn't gather up our like terms. And so from this point forward, we'd have n equals 8. So now we're going to try 3 together, and I'm going to have you try 6 on your own. And I know that these lessons are going a little bit longer, but I also know that we don't have an opportunity all the time to talk to each other during this particular session. So I want to make sure that I'm clarifying as much as possible. So as we move to the beginning, we want to simplify, and the directions even ask us to do it. It says combine, then solve the following. And we need to show all the necessary steps. So I'm going to start by gathering up my like terms. I see a group of x's, so I'm going to gather up 10 x's, and I see minus 5x. So if I think about this as 10x minus 5x, then I'm going to have 5x left over. I work on that operation. So now I'm going to head to my constants. I have a negative 4, and to that negative 4 I'm going to add positive 7, and together that would equal positive 3. By the way, once again, I'm always going to encourage the use of a calculator. If you have it, use it. And this was just hanging out waiting for us to finish simplifying. Now we have your basic two-step equation with a coefficient and a constant. And so we've been able to take 4 terms and just make them 2. That's the beauty of this. Now this makes it much easier in our brain to know what to do to solve. I'm going to start with the constant by basically eliminating it using the opposite operation. So it's going to eliminate, and I'm going to have 5x left over. And this is a little bit tricky. If I have negative 47 minus 3, my brain is thinking negative 44, but it's not. If I'm at negative 47 on the number line, and I'm taking away 3, I'm moving down the number line further into the negatives. So my answer would be negative 50. So our last solving step, we have coefficients. Side by side means multiply. So we're going to do the opposite. We're going to divide by 5 on both sides. So we've eliminated that 5, leaving what we wanted, our x, our variable all by itself, called isolating the variable. And a negative 50 divided by a positive 5 is going to be a negative 10. So our solution is negative 10. Let's try the next one. sometimes they give us the answer, so to speak, on this side, and we have more of our information we need to simplify on the opposite side. So once again, I'm going to start on the side where I need to simplify. And it doesn't matter what I start with. So if I start right here with my constant, I'm going to gather up any more constants I see, which is the 8. So I have a negative 15 plus 8. So that would be negative 7. Then this particular term doesn't have any matches. There's no other W's, so I'm just going to drop it down as is, including the sign. And then that 17 is just kind of hanging out, waiting for me to finish that. So when I solve, and I know sometimes it's confusing when it's written in what I'm going to call backward, I really want to start on the side that has the variable, wherever the variable is. And there's the coefficient, and this is a constant. These are also kind of switched around from how we sometimes see them traditionally, but I always want to get rid of the constant first. So I'm going to do the opposite of negative 7. I can look at this like it's positive 7 or adding 7, whichever helps you out. So I now have 24 on this side, and on the other side, since this has been eliminated, I have positive 4W, so I can just write that. That plus 4W is the same as positive 4W, so I drop that down. We're going to continue solving. Again, we look on the side with the variable. That lets us know what we need to do. The opposite of multiplying by 4 is to divide by 4, and that leaves 6 equals W. Again, you can pause at any point. So now let's try one that has a little bit more, or a few more terms to gather up. All right, as we look at this, and it doesn't really matter what term I start with, I'm just going to go ahead and start with the first term. I have a negative 7, I have a positive 10, and I have a positive 2. And I can add those numbers in any particular order. I think adding these two right now might be easier because they're both positive, and 10 plus 2 would be 12. And then I'm going to add that negative 7. Or I could have said negative 7 plus 10, that would have been positive 3, and positive 3 plus 2 more would be 5. Either way, we're going to get 5. So when I have a variable that does not have a coefficient, we always use number 1. If I didn't clearly state that before, I have 4a, but in front of that is a negative 4a, so positive 1, and a negative 4 would be negative 3, and then we bring the a along with it. So this is what our equation, we've been able to whittle it down to a two-step equation, a constant and a coefficient. So now we're ready to solve. I want to make sure I undo or get rid of, eliminate the constant first. That's the number without the variable. So that's eliminated, leaving minus 3a. So I'm going to look at that like it's negative 3a. And on this side, 32 minus 5 would be 27. We're going to continue our solving by dividing, and here's where it gets tricky. If I have a negative number, my opposite thing I'm going to do is not a positive 3. My opposite is to divide, because side by side here means multiply, so I'm going to do the opposite of multiplying. So I'm going to divide by negative 3. That's another place to make an error, because up here I used opposite signs because I was using addition and subtraction. Here I'm using multiplication and division. So our answer would then be A equals negative 9. So I hope this was helpful. You can go ahead now and go to the next page, and please try 6 on your own.